inside a cup. Believe it or not, as I swing this board with a string, this water will not spill.
Mira lo que se avecina a la vuelta de la esquina, viene Diego rumbeando, con la luna en las pupilas y en su traje agua marina van restos de contrabando. Y donde más no cabe un alma y se mete a darse caña poseído por el ritmo ragatanga. Y el DJ que lo conoce toca el himno de las 12 para Diego, la canción más deseada. Y la baila, y la goza, y la canta. Y ahí se
Can you change the direction of an object moving in a circular path without changing its speed? Yes, you can. But what does it look like having a constant speed but in a different direction? This is what it looks like having a constant speed but changing direction. So velocity is a vector since it has a magnitude and a direction. Uniform circular motion is a motion in a circular path having constant radius and a constant speed. In a uniform circular motion, there is instantaneous velocity and it's always tangent to the circle. 2 by r is the distance of the object moves around the circle. Period is the time of the object to make one revolution in the circle.
Moving on, as Colleen said earlier, to have a uniform circular motion, an object must have a centripetal acceleration. And this is the derivation of the formula for the centripetal acceleration. So we have the change in velocity over velocity is equal to velocity multiplied the change in time over radius. And rearranging the formula, you will have the final formula for the centripetal acceleration, which is v squared over r. So what is centripetal acceleration? Centripetal acceleration is a form of acceleration an object is undergoing to when it is moving in a uniform circular motion. And it is denoted by a small letter a with a subscript of c. And the final formula is a sub c is equal to v squared over r. Velocity is also called the radial acceleration, and it is pointing towards the center. So, as you can see in this diagram, suppose this diagram is the water activity earlier at an instant. V sub 1 is the velocity of the object at time 0. V sub 2 is the velocity of the object at time 1. And the change in V is the change in velocity or the acceleration. Looking at the green arrows in the diagram, we would see that the arrow for the change in velocity or the change in V is pointing towards the center. And this shows that the direction of the acceleration is towards the center. So moving on, for an object to move in a uniform circular motion, there must be a net force acting on it. And according to Newton's first law of motion, an object will continue to move in a straight line or in a straight path unless acted upon by an unbalanced force. And this external force is what we call the centripetal force. And using the famous equation FMA, we could derive the formula for the centripetal force. We will just have to change the A in the FMA into the acceleration or the radial acceleration, and then we will have the equation for the centripetal force, which is the m multiplied to v squared over r. Centripetal force is not another type of force like tension, gravity, or normal force. It can be any of those. For example, the water activity earlier, the tension force on the string is also the centripetal force that causes the object to follow a circular path. So, in relation to centripetal force, you might have heard of centrifugal force. There is no such thing as centrifugal force or a force that is pointing outwards. What happens is that the natural tendency of an object to move in a straight line must be overcome, and that is the feeling that most people commonly mistake as the centrifugal force. When centripetal force vanishes, the object will fly off tangent to the circle as per Newton's first law of motion. As you can see on the picture above, the object